Literate computing, or the mixing of code and narrative about the code and code results, has a long history with contributions to the idea reaching back from its creator Donald Knuth all the way to kind of more recent implementations like Mathematica and MATLAB. More recently, we've seen how the introduction of Jupyter Notebooks has revolutionized how people explore data with Python and other languages. Well, RStudio Inc., a small company focused on the R programming language, has built an ecosystem of tools that brings the next level of literate programming capabilities to the R programming language, while nicely incorporating the reporting and analysis tools that have been a hallmark of the R programming language in the past. Today, we'll get an introduction to how a few of these tools work and see how they can be deployed on the Hub as resources and as tools. So we'll start by launching the RStudio IDE. If you're not familiar with the IDE, some people they prefer to use this IDE when working with their R scripts because it's full of features and it's easy to use. So you can try it out on the HUBzero.org website if it's not already installed on your Hub. First, we'll navigate to the Hub web page and log in. After you've logged in, navigate to the dashboard and then look in the My Tools module for the RStudio application. You can type it in the little search box and it should come up. Once you find the application, click on the Launch Tool button. So you'll notice right off the bat that it doesn't launch a normal VNC viewer that you might be used to with other tools. Instead, the user is served an HTML and JavaScript based user interface. This is the RStudio IDE, and there are four main parts to the IDE. The first section is the code section, or the code pane, and this is where users can manipulate their source code. Next, we have the console, where R commands are executed. Next, we have the environment and history pane, which shows variables and files that have been loaded into the IDE environment. And the viewer pane shows output that can be visualized. Now, to write code, you'll use the File New menu to open up a new file. Now, there are a couple of different types of files that you can open. As you would expect, if you were going to write R scripts or R programs, you can open up a file for R scripts. But there's three types of files that I'd like to highlight today. Those are the Shiny applications, the R Markdown files, and the closely related R notebooks. The R programming language has a long history of allowing people to easily generate reports. People have been using tools like SWeave to combine their R code with plots, R code and plots into other documents like LaTeX for many years now. So RStudio, the company behind the graphical user interface, they've been focusing on building ways for people to more easily disseminate their research results and analysis, particularly on the web. Two packages that they've developed to help make this happen are Shiny and R Markdown. Shiny is a toolkit that allows users to put together web applications. It includes things like normal input widgets that you'd expect, sliders, radio buttons, drop-down menus. And it also has a couple of output widgets like text boxes and static plots. It includes a number of interactive output widgets that are backed by JavaScript libraries like Leaflet for mapping, Plotly for plotting, and data tables. And Shiny allows users to fully describe their layout by using a grid system or one of their predefined templates. So it's important to note that Shiny applications are backed by a Shiny server, which produces HTML, CSS, and JavaScript that gets rendered in the user's web browser. Let's check out a couple of examples. The first example is a simple application called Spirograph. Let's take a look. So I'll go ahead and get this application running. If you're not familiar with the Spirograph, it's kind of an old-timey tool, or old-timey toy, where you have multiple gears that are interacting with each other, and you kind of stick a pencil down as attached to one of the gears, and as the gears turn, your pencil will draw out a shape, and turns out that somebody got an idea that the Spirograph can be approximated by the gears can be approximated by a mathematical formula, and so they described how to write that formula, and then we took that and created a program out of it. So you can see here we have a simple Shiny application, a couple of sliders for inputs, and as we change the sliders, almost instantaneously the output result that we see on the right hand side of the screen also changes. So what's going on behind the scenes? You can see we have this is basically the code for our application. We have a simple function that describes the math formula for a spirograph, a three-geared spirograph, and it accepts three input values, N1, N2, and N3, and those are our input values that we have from slider inputs from the user. And then separately, we have a description of the graphical user interface. So we have a title. You see our title is Spirograph. We have three slider inputs, and you can see N1, N2, and N3 are our three slider inputs. And then we also have a main panel which includes our the output plot, and that's what we see here on the right hand side. So this is a pretty simple Shiny application. Let's take a look at another. This second one is the Indiana precipitation example. In this example, we had collected some precipitation data from many stations that were across the state of Indiana, and they've been holding the data for since about the 1940s, 1950s. They've been collecting data, and they make this data public. So we built a small application that puts a marker on a map at each location, longitude, latitude location where a monitoring station is located. And when you click on the marker, it loads up the station name, the station ID, the latitude, and the longitude. And for each marker, we also load on the side a XY plot, or a bar chart of the, I guess this is XY, it's probably XY plot, showing the precipitation values for each, the historical values. So since about 1948-ish, 1945 in some cases, all the way up into the early 2000s, they have data for this. So this is another example of a Shiny application. So our Markdown is a type of markup language that's based on the Markdown wiki syntax and holds a few additional features, including being able to hold and run our code. So this allows us to quickly write text explanations that are rich with formatting and structure and code chunks embedded within it. You can also embed output from the code chunks, like graphs and tables and numeric values. Once you're done, these files can be converted to HTML for distribution as web pages, or you can convert them to PDF files, or Word documents, or LaTeX documents, or a handful of other formats. So that's one of the real strengths of this system. Let's check out some examples of our Markdown files. The first one we have up is a simple markup example. Now, if you're already familiar with the markup syntax, then a file like this should look familiar to you. Let's take a look. So once rendered, this is just a plain HTML web page. And there's nothing interactive on this, like the plot isn't interactive like in our first Shiny example. You remember that we could change the values of our Spirograph and see the plot change. It doesn't happen here because this is just straight up HTML. But the thing to note is that we were able to put together a document that has a little bit of narrative. It has a code chunk or two, and then it displays the results. And so we can see the syntax behind that. Here we have the narrative that we write looks like it's pretty much plain text. There are a few simple markup elements that we see going on here. One, here's a markup to describe the equation for the Spirograph, and we see that right over here. You see code chunks. So code chunks can be embedded right within your markup file. So that's important. If you're describing something, you kind of want the code that you're describing to be near the description. So you can see how we can just lay out a whole web page of values. And then this plot is it's just showing the result of running our code chunk. So not only is this code chunk displayed, but internally this code chunk is run. The value is stored in the variable result, and then down here when we call ggplot, you can see that we're using that result to create our XY graph. So that is a simple R Markdown file that can be rendered as HTML. Next, I'd like to show you an example of a R notebook that has embedded HTML widgets. So we never really talked about the HTML widgets before, but I mentioned earlier that that within Shiny applications you can have these HTML widgets as outputs. You can also include HTML widgets within your R Markdown file. So let me clear this one out. One thing I like to use our Markdown files for is if I have a kind of a long explanation of a process that I took that involves maybe multiple pieces of code, or is something that I needed to do in a certain order. I like to include, if I'm explaining it to somebody else, I like to tell them or give them this an R Markdown or R notebook kind of file, so that I can put a text narrative in the file, and then put code. I can just embed the code right in there. So in this case, this is a notebook that kind of describes how we put together the second Shiny application we saw with the Indiana precipitation data. And so this has the narrative part here. You can see the embedded code chunk on lines 22 through 28, and we can run these code chunks. So we should probably run them in order. Let's see, it's loading libraries there. So here it's loading up a table. Let's see if it can, there we go. It's loading up a table of data. And we're talking about the longitude and latitude fields, and we're creating a map object here. But if you didn't want to run each one in order, if you didn't want to run them by hand, clicking on each one thing I usually do is go through and just click on the Run All button here. And as you can see, there's a little meter at the bottom that's describing where it's at in the process, and we'll go through and render all of your code chunks. So now this becomes something that you can kind of go through, and you see the three pieces that we like to see in notebooks: narrative, code, and then the result of running that code. Helps with an explanation. So you can render this as HTML or PDF as well, and hand that off to somebody. There's one important piece to note about our notebooks is that there's usually two files involved. There's your RMD file, which is just the code. There's no output that's stored in the RMD file, but probably the more complete file is one that has an ending of .nb.html, and that notebook HTML file is an HTML file that you can render in any web browser, but it also includes the R Markdown code that was used to generate the file. So you can hand that off to anybody, and they can open it up in a web browser if they just want to view it, or they can open it up in RStudio if they want to actually manipulate the underlying notebook. So that's a good thing to keep around. Usually if I'm putting these into a source code repository, I will include both in the source code repository. And the last example I want to show you is an R Markdown example with shiny widgets embedded within it. So we'll go back to our Spirograph example. So here is similar to the first R Markdown file we saw, where we have explanation of what a spirograph is, the equation that describes a spirograph. But in this example, let me go ahead and get this one kicked off. In this example, instead of showing the static page that describes or a static image that describes the output of the spirograph, we're going to embed an interactive some interactive shiny widgets inside of that page. So let's see what that looks like here. That is loading up right now. Alright. So this should look familiar. This is the same beginning part as we saw in our first R Markdown example, with the explanation, what the equation looks like. But now we have these separate shiny widgets. So we have three input sliders, and then we have a shiny output. We have our interactive XY plot down at the bottom. That one looks kind of interesting. Alright, so what's going on behind the scenes? If we go back to our shiny code, we can see that we just took the many pieces of our first shiny application, and we just used the widgets instead. We could have also embedded a whole shiny widget inside of our Markdown file. So if you build your own shiny widget, which could be a combination of other shiny widgets, if you build your own Shiny widget, you can embed that within an R Markdown file. And I like to do that when I have maybe I have an application where before I show the application, I just want to give a little bit of introduction to what's going on in the science or in the science code, and then I want to show the application at the bottom of the web page. So that's kind of what we've done here. A little bit of explanation about the science or the math that's going on, and then here's the application. So you can publish any of these types of applications or interactive reports on Hub. In order to do this, you have to use the same tool contribution process as what you use with all the other tools. In the Contrib tool interface, we've added a switch which tells the middleware to launch the application as a Weber or a Jupyter Notebook style of application, where we're streaming the HTML, the CSS, and the JavaScript back to the user's web browser, instead of using the VNC-based viewer. If you're familiar with if you're familiar with the tool contribution process for the Hub, then you know that we require 4 things in order to get your application published. And publishing Shiny and R Markdown applications is no different. First, we need the source code in a source code repository. Second, we need there to be a graphical user interface. And since these are web applications and web pages, the graphical user interface can be created using HTML and JavaScript. It's always a good idea to include a makefile that describes how to compile and install your application. In the case where you have an application of just a static web page, we can install the files into a www directory, but we can also pre-render these files so that they come up nice and fast. For Shiny applications and for our Markdown applications, our reports, these files can be installed in the bin directory or in the www data directory. And lastly, we need an invoke script which tells us how to launch the application. For Shiny and R Markdown applications, we generally launch a rewrite server or rewrite proxy in front of the application. And you can see that happening here. That's what this Roxy command for Roxy proxy is. So that will run in front of your application. And then you can launch your R Shiny application or your R Markdown application with the wrap run command. So hand your application off to wrap run, and it tries pretty hard to figure out what type of application it is and launch it appropriately. So if you're using RStudio, or if you're building R-based applications using Shiny and Markdown, then let's keep the conversation going. Send us an email, or better yet, put in a support ticket. If this is not available on your Hub, we can get you started with how to install it on your Hub, or if we are maintaining your Hub, then we can work together to figure out how we can provide better solutions for our users to be able to publish their applications on the Hub. Thanks for listening.